Mission 8, Experiment 8. Starting the client. Motion script sent. Path sent. Start experiment has been sent. Mission 8, Experiment 8, this is Robot Guinness. Microcontroller has been physically modified to reseat the expansion board and to loosen the cable that connects the compass to the microcontroller. By loosen I mean extend it a little bit so that's not so tight of a stretch. There it is, going in appears to be a wide arc. In order for it to reach waypoint 2, it needs to turn left quite a bit. There it is. Waypoint 2 is actually over there. So we need to figure out why does Guinness make such a long arc in order to get to the second waypoint, or in order to get to any waypoint. It seems to make long, wide arcs. It's still moving. What that means is it doesn't think it's reached the waypoint yet, but it's moving slowly, meaning it thinks it's getting close to the waypoint. Waypoint 2 reached. Now it's going to have to do about a 180-degree turn. There's the 180-degree turn. Now the Ferris middleware has been modified so that it records the GPS coordinates, the GPS data, the raw data that's coming in. So we should be able to analyze that. Seems to be approaching the next waypoint, which is why it's running so slowly. See, the next waypoint is just about one parking length in the head. So here's the third waypoint has been reached. One possible cause for the wide arcs is the front servo may not be turning at the rate that the software thinks it should be turning at. So the software tells it to turn in a certain angle, but in fact it's not. So that's why it's going in an arc. But then as it slows down, the turning radius decreases, at least in the software. What that means is as the robot goes slower, the turning radius, the robot is able to turn sharper, and that's why it corrects at the end. That might be the explanation. Alright, that was, I believe, the fourth waypoint. Now we're heading towards the fifth. Again, it's a kind of a wide arc. If this hypothesis is true, that the front servo isn't turning at the rate that the software thinks it should be turning at, if we increase the rate at which it can turn at all speeds, maybe the line would become straighter. But I think what this means is we need to decouple the turning pulse width modulated signal from the from an actual unit, since the digital data that we have, which is currently the actual turning angle that we want, may not correspond to a specific pulse width on each robot. each robot, in other words, will have a different pulse width corresponding to a particular turn. So if we analyze the data and we compare the heading error relative to the time, I think what we'll see is the heading error doesn't like slowly decreases, which is the arc that we see, and that's because the turning radius has been too restrictive, at least on robot Guinness. All right, it's reached the 7th waypoint. Oh, no, sorry, the 6th waypoint. This is the 6th waypoint. And now it's heading towards the 7th. Now remember, really the only thing changed was the extension board on the microcontroller was reseated. I shortened the 2 pins that are right next to, I think that right next to the power, I'm not really sure. There's 2 pins that need to be shortened a little bit in order for the extension board to seat fully in, otherwise it'll be poking out a little bit on one end. Another thing I changed was the compass cables that connect the compass to the microcontroller. I lengthened it by not strapping it so tightly down so that they can have some play. And I'm wondering whether or not that has anything to do with the quality of the GPS signal, like whether or not by being too tight, maybe it's more sensitive to vibration. We'll see. So the robot is heading now towards waypoint 8. This is mission 8, experiment 8 with robot Guinness. Robot Guinness is moving very slowly. It's right now it's about it's about almost exactly 1 parking width to the east of the actual waypoint. Let me see what the GPS accuracy is. According to the screen here, the GPS accuracy is about 20 feet. So the fact that it got that close to the waypoint is pretty good. Might be because the waypoint marker itself is off by some 20-some feet or something. I believe each of these parking spaces is about 10-foot width. We'll have to measure that. And this is robot Guinness. Behaving much better now. Alright, robot Guinness has reached waypoint number 9. This is mission 8, experiment 8. Mission 8, Experiment 8, Robot Guinness has reached waypoint 10. It's still moving slowly. Okay, now it has reached waypoint 10. It pauses for 4 seconds and that's going to head towards the final waypoint. Mission 8, Experiment 8. Robot Guinness is approaching the final waypoint. It is now slowing down so that it can get more accurate arrival of the final waypoint. Final waypoint reached. Mission 8, Experiment 8 was successful.